from this video. So let's first try to organize interfaces a little bit. So as I mentioned, we have universal interfaces and image transfer interfaces for internal interfaces. So the interfaces that are embedded into the device. And universal mean we can send other data through them, not only image. And because they are universal, they are usually not perfect for image transfer, because in most of the displays that we use nowadays, the image transfer is one of the most demanding. So the bit rate, the data transfer for the image usually is very high and higher that many universal interfaces can give us. But if we need to send like image only once per some time, we don't need very high bandwidth, we don't have the live video, for example, then we can use some of the internal universal interfaces such as SPI, I2C, or even as slow interfaces as RS232 or UART that are very similar. So this is the first slide to organize a little bit the interfaces, and let's jump into more details. So first, universal interface will be SPI. That is a serial peripheral interface. So that means this interface is a serial, of course, and it's used to communicate between a host, the master called in SPI, and the devices that usually we call slave. One host can communicate to many slaves. To select the slave, we use the chip select or SS line, and then we use two data lines, the master output or master input, and of course the clock to synchronize the data, because this is the clock synchronized interface. It can be fast, but not fast enough usually for the live video images. So we can have, baud rate here like 1 megabit, but can be like 10 megabit or even 50 megabit on the SPI or QSPI, which is a quad SPI kind of modification of SPI that is faster. But still, this interface is very universal. So you use it to connect memory or some input-output ICs in between internally of our device. Yes, SPI in a display world is used for a simple displays, for usually the small sizes displays, where we can transfer the image relatively fast because the resolution is low. So I would say that the maximum here for SPI display would be maybe 3.5 inch 320 by 240 TFT display. If we have higher resolution, usually the image transfer will be too slow to use SPI, even with high-speed SPI. Then we have the I2C interface. This kind of interface is usually slower than SPI. It uses only two lines, so one is clock for synchronization and the other one is a data line, and then data line here is bidirectional. So in SPI we have two data lines, one outgoing and one incoming, and in I2C interface we have only one data line. So if, for example, master is sending some data, the slaves can only receive it, and the master then need to finish it. We need to wait a little bit, then we can respond as a slave to the master. And here also to select the slave, it works a little bit different, because in SPI, as you remember, we had this chip select line, CS line or SS line, and here we need to send first the address, the logical address we need to send to the interface that is being written by the slaves. But in general, this is slow and universal interface used also to connect maybe the simple memory and some other ICs that we have around our microcontroller on the PCB. Very useful, but usually not used for the image transfer. This interface is very popular in a display UART for the touch screens. Yes, so most of the embedded touch screens that we use, they have I2C interface, because the touch screen do not generate many data. We have only coordinates of the finger or few fingers at most that need to be sent back to the microcontroller, to the processor of the device. So the slow baud rate is well enough for the touch screen, but not enough for the image. Then the next interface, a very old interface nowadays, is RS232. So this is also serial slow interface that can be used internally in the device or externally. Actually, this interface is not only internal, can be external, and we see the external connectors here, but it's still being used internally because it has its variation, that is UART. So UART is basically the same as RS232, but it's a fully internal interface, pretty slow. We have a TX line and a RX, that is a transmit line and receive line. We don't have a clock here, we only have a clock as a synchronized internally into the devices, but the clock is not being sent out. So we need to synchronize with the data that is coming through the lines, and to do that we actually need to set the same baud rate on the sides of the communication line. So before we use UART, we need to agree first what speed we will use. That is not a case in a SPI or I2C, because we have a clock there, and the clock there gives the speed to everyone. Yes, so everyone works according to the clock. In UART we don't have a clock, so first we need to agree what speed we will use. UART is rather not used for the image transfer, or it's very slow. So maybe UART or SPI or I2C, they can be used for displays, but for as I mentioned, low resolution displays could be SPI, but for high resolution displays we need intelligent display. So we need a display that will generate the image internally, and through this slow universal interfaces we only send commands, or maybe we send image once and it's being stored into the internal memory of intelligent display that we will use later, sending the right command. Yes, so intelligent line of displays, you can find it on our website. We have very advanced intelligent displays made with a BridgeTech controllers. They use SPI and QSPI for communication. That means your software, your system, your microcontroller can be simple. You can use SPI interface to drive them, and still you can have high resolution, even as high as 1280 by 800 in a 10.1 inch display with the relatively simple microcontroller and a simple software to drive it. So as I said, if you want to use a slow universal interface, you need to use intelligent display. Then